So just to summarize, one thing that will really help you with these problems is to remember when you add vectors together. Right now this picture is showing two forces acting on a single object. So those two forces are acting together. That means we need to add the forces together to find the resultant. But if you recall from last time, we said that in order to add forces together, we actually put the end of one vector on the beginning of the other, right? We line them up. So right now they're both starting the same point. That doesn't work to add them together visually. So this one would need to be drawn here instead. So it's the same length, going the same direction. We're just putting it in a slightly different location. And what that ends up doing is creating a parallelogram. If you also realize that creating a parallelogram will help you find things that you're missing, okay? So this is the vector we moved up here. It's still the same length because opposite sides in a parallelogram are congruent. And we've made it parallel because it's going the same direction it originally was. And it's kind of created a parallelogram by doing that. Does that make sense why we would need to know things about parallelograms because of that? Alright. Two draft horses are pulling on a tree stump with forces of 200 pounds and 300 pounds as shown. If the angle between the forces is 65 degrees, then what is the magnitude of the resultant force? What is the angle between the resultant force and the 300-pound force? So we have two questions to answer. I'm going to finish my picture to help me answer it. So the resultant force is the one that goes from the beginning of the first vector to the end of the last vector, right? So that's one of the answers we're trying to find, is that length right there. That's the first question. Then the second question, what is the angle between the resultant force and the 300-pound force? So what angle is that tree stump going to go as compared to this horse here? Okay, so we're looking for that angle right there. When we're done, I'll just kind of mark that. Okay, so let's see what we know here. We know that this side of our triangle is 200 pounds, which I realize it's kind of weird to talk about the length of our triangle being 200 pounds, because pounds is a measurement of force. Sometimes we say it's a measurement of weight, but it's really more of a measurement of force. And then, well, I guess it's also weight, because weight by definition is just the force of gravity acting on an object's mass. So it's still weight either way. But this time we're going to treat it like a distance, but we still just call it 200 pounds, okay? And then this side is 300 pounds, and we're trying to find this side here. So we have this little oblique triangle in there. Does everybody see that, or do you need me to separate it? We're good? Okay. So we have this little oblique triangle, and we have two sides, and we're trying to find the other side. I'm thinking it would probably be best if we could use law of cosines if we had a side angle side. But right now we don't know this angle. However, is it quite easy to find it? Yes, it's very easy to find it. So I'm just going to label that alpha right now, and tell me how to find that angle alpha. Yes, because of what I just said about parallelograms, the consecutive angles add up to 180. So 180 minus 65, because that's this and this angle in our parallelogram. So that gives us what, 115? Okay, so now we just need to remember how to use law of cosines to find x. X will be the square root of 200 squared plus 300 squared minus 2 times 200 times 300. Notice how it's really handy if you have that formula memorized and don't have to keep looking it up. And then cosine of 115. Okay, put it in your calculator. Tell me what you get. Remember when you're putting these in the calculator to be very careful, to follow order of operations with parentheses if needed. You shouldn't have to put parentheses around these like I did though. This one's not really too bad to plug in, honestly. It's when we're finding an angle using the law of cosines that it becomes really tricky. Or if you're using a calculator that goes backwards, like your iPod, just the regular iPod calculators do. The other issue you want to make sure of is make sure your calculator is in degree mode. I'm not sure mine is, so actually it's not in degree mode. I'm glad I checked that because that would have given me the wrong answer. Okay, what'd you guys get? Yeah, I'd really like everyone to try it because I find that calculator errors are the most common. Okay, so I agree with Kyle here. I got 425.1 pound force with the two horses working together. So, you know, you think you have two horses working together and one's working with a force of 200 and one's working with a force of 300. Why isn't the force just 500? That would only be if the forces were going exactly the same direction, which they're not, right? So it just, that's just how it works with vectors, so. All right, next. The next thing we need to do is find theta. So far we've just been working with this upper triangle, and I drew theta down here in this bottom triangle. But you might remember something from geometry about alternate interior angles. Yep, so this angle right here is the same. So if we just focus on the same triangle we were using, we can just find that angle. We can now use law of sines because we can find the angle of that, we can find that angle because it's across from the 200. And we now have x, which is the angle across from alpha, which was 115. Right? So we should be able to use law of sines. So sine of alpha over 200 should be equal to sine of 115 over 425.1. Then we just cross multiply, so sine of alpha is equal to 200 times the sine of 115, the whole thing divided by 425.1. So then we just put it in the calculator and do the inverse sine of that thing to get our theta. Make sure your calculator is in degrees. Make sure you close the parentheses after the sine of 115 if it puts parentheses in there for you. What do you get? Okay, so I get that the angle between those is 25.2 degrees. So see how we simply used solving a triangle to solve a problem with vectors. That wasn't bad, right?